Well, kids, now you know that CO2 started to be measured directly and continuously since the 1950s, but we have found ways to go back in time to infer past CO2 estimates. And typically, you try to see if it was higher than at the present time or lower than at the present time, depending on what kind of clues you get. So we are talking about ice cores, and we mentioned that glaciers basically grow by compressing snow and can keep growing for a long time, millions of years, literally sometimes, because Antarctica started glaciating some 34 million years ago or so, and you can imagine kilometers thick ice. Glaciers have lots of information in them, but ice ages come and go. You might have seen the movie. Why does that happen? Here is where it's critical to understand that when a little perturbation happens in the sun's energy coming in because the obliquity changed, the orbit's ellipticity changed, or the precession changed, and so on, it's not always the amount of energy, but the distribution from season to season can change, and that can trigger a cooler temperature. Let's say because there were a lot of glaciers, and glaciers started to grow because you reduce the amount of energy coming in because of the orbital changes. If glaciers grow, albedo increases, more energy goes back, temperatures get colder, but also humidity gets lower because drier temperatures can hold lesser humidity. So snowfall rates also slow down. So glaciers grow, but they grow slower and slower as temperatures get colder and colder. But the other way, if energy suddenly increases and the glaciers begin to melt, then the albedo decreases, you keep more energy and heat goes up, like the greenhouse gas effect, and then more glaciers melt, less albedo further, and more energy in the system because you're reflecting less, and then you can accelerate the glacier melt very fast. So you have these nice sawtooth patterns in the podcast. You look at the CO2 from the past, and there are reasons why when there is an ice age, CO2 gets trapped in the oceans and on land under the glaciers, under sea ice, and so on. And when glaciers melt, all that gets released. So naturally, CO2 goes up when the glaciers melt, and CO2 goes down when the glaciers grow. And now you have to think about what we are doing now. We are increasing CO2, we are melting glaciers, we are further increasing CO2 and warming and creating this glacier melt, which is what is happening on Greenland and Antarctica, right? Get back to me with questions, kids.